Okay, so today we're going to talk about hyperbolas. The definition of a hyperbola is the set of all points where the absolute value of the differences of the distances to the foci is constant. Now it's very similar to an ellipse. So this formula is like the ellipse one, except it has subtraction instead of addition. And the reason why it has absolute value around it is because when you're subtracting two things, like if this one's larger, you would have negative, but we want that value to be equal to what used to be called the major axis for an ellipse, but in hyperbola it's called the transverse axis. All right, so the two equations for a hyperbola are listed here. Now, this, you'll notice, is subtraction as opposed to addition. With ellipses, it was addition. And with an ellipse, you would look at what's the larger of the two numbers on the denominator, and that would tell you which one's the major versus the minor axis. For here, the most important thing to look at for a hyperbola is what variable comes first. So if you have an x that comes first, then this is a hyperbola that opens left and right. Okay. If you have the y that comes first, it would open in the y direction, which means that it would open up and down. All right. In a hyperbola, you also have asymptotes. Now these asymptotes are going to be diagonal asymptotes. Okay, so one other difference between the two equations is you'll find the slope of the asymptotes, which is always like the change in whatever's under the y over change in whatever's under the x. So this is b over a. Here we're going to do change in whatever's under the y over the change in whatever's under the x. So that's a over b. All right, but just like anything else, the center is hk. Now notice that h is next to the x, right, and k is next to the y. So that's how it should be, but these are flip-flopped, right, because y came first. Everything else is pretty much the same as what we've done before. You have a transverse and conjugate axis, which is 2 times a and 2 times b. They're just not called major and minor. It's like an ellipse, but there's no major and minor because this number doesn't necessarily have to be larger than this number. So they don't call it major and minor. The eccentricity, that's still the same. It's c over a. C is going to be how far away your foci are from the center. But to find c, you're going to do a squared plus b squared, which is the Pythagorean theorem. Okay? With an ellipse, it was a squared minus b squared, so just don't mix those two up. I guess you could think of it as with a hyperbola, there's a minus, and so in your c equation, there's the plus. Right? With an ellipse, there's a minus, but in your original equation, there was a plus. Think of it how you want to. All right, so the last two things are the foci and the vertices. Foci are going to be c units away from the center along the transverse axis. For an ellipse, it was along the major axis, but same concept. And vertices are where your hyperbola, the two pieces, start, and those are going to be along the transverse axis, so the endpoints of the transverse axis. All right, if you need to pause the video, go ahead. Otherwise, we're going to do a couple of examples. All right, so we're going to start off by graphing. We're going to do page 864, number 5, 13, 19, 27, and 29. So the first one we're going to deal with is a graphing problem. It asks you to graph 16x squared minus 25y squared equals 400. So I know it's a hyperbola because it's got x squareds and y squareds, but it's got subtraction in it as opposed to addition. All right, so then I know I'm going to try to fit one of these formulas. And I know it has to equal 1, so the first thing I'm going to do, I'm going to divide by 400. Now usually you get nice fractions that reduce from here. So 16 over 400 is going to give you 1/25th, which means this is going to be x squared over 5 squared, and this gives you 1/16th. So y squared over 4 squared equals 1. Okay, so first thing is make your equation look like one of these. Now, it's helpful to look at the variable at the beginning. So that tells me that it's going to open left and right. Okay, my center did not get moved from the origin, so it's going to start at 0, 0. All right, so I'm going to graph this, and I think it's easy to graph first and then answer the questions later. So I'm going to start at 0, 0. I'm going to go this much in the x direction. So 5 units left and right. Now, because this came first, this is the endpoint of my transverse axis, right? So this is my vertex, this is my center, this is another vertex. I'm going to go up and down 4. Right? So this should be very similar to drawing an ellipse. Now, in an ellipse, you would just be done. With a hyperbola, we're going to create this little box that's not actually part of your hyperbola. It's more of a reference box. Right? But from this box, we can connect the diagonals, and these are our asymptotes. Okay, so my asymptotes usually just asks you for the slope. Sometimes it'll ask you for an actual equation. Okay. This one, if I look at my slope, it's up 4 and over 5, which is the change in y, right, that number, over the change in x. And since it starts at the origin, my equation is y equals 5 over 4x. This one is going to be very similar. It's y equals negative 5 over 4x. So those are the equations of my asymptotes. Now, again, those are just reference points or reference lines because you haven't actually drawn in your hyperbola. My hyperbola, pay attention to the x. It's going to open along my x direction. This should probably go a little closer to that. Because remember, with any asymptote, your graph is going to get really, really close to it, but never actually cross it. Okay, so it's going to get infinitely close there. All right, so my graph is done. The actual hyperbola is here. So any point on the hyperbola, if I look at my foci, which I have to find where those are, okay, so my foci are going to be, I need to figure out what c squared equals a squared plus b squared. So 25 plus 16, that's 41. So that tells me that my focal points are going to be square root of 41 units away from my center. So on my graph. So that gives me about 6.4. Okay, so I'm just going to label this was 5, 6. So about here. Here's one focal point. Here's another focal point. All right, so back to our definition. The distance between any point, let's say this is my point, the distance between the focal point and the focal point and that point, if I subtract, like this one would be the longer one minus the shorter one, that distance should be equal to the distance, the length of my transverse axis. Okay, so that's your definition. Where are the actual focal points? They're at plus or minus root 41, 41, comma 0. All right, we also need to find our vertices. Vertices are at plus or minus 5, comma 0. And the length of my transverse axis is 10, because I went 5 in each direction. My conjugate axis is 4 in each direction, so that's 8. I need to find my eccentricity, which is c over a, so root 41 over 5. All right, now these are always going to be, the eccentricity is always going to be greater than 1. Because think of it like c has to be your like hypotenuse, right? So that's always going to be larger than that number. All right, so I believe that we found all the things we needed to. All right, we're going to do next example. So number 13 is pretty much the same problem. It's y minus 2 squared over 2 squared equal minus x minus 1 squared over 1 squared equals 1. All right, so again, we're going to graph. The nice thing about this one is that it's already equal to 1, so we don't need to solve. All right, so we still need to identify where are the vertices, the foci, the length of the transverse and conjugate axes, the eccentricity, and the equation of the asymptote. All right, so let's graph this one. Now notice that it starts with a y, so this one's going to open up and down. So we're going to start at 1 comma 2. So just like I almost did, be careful, your x coordinate has to come first. All right, so I'm going to start at 1 comma 2. Now from there, I'm going to go this much in the y direction. up 2 and down 2. Since this came first, these are my vertices. So this is my center, vertex, vertex. So I can list where my vertices are. They are at 1, comma, and then 2 plus 2 and 2 minus 2. So 1, comma 4 and 1, comma 0. All right, my transverse axis, you can count the units, that's 4 units. My conjugate axis, I have to go 1 unit in each direction. So that is 2 units long. All right, now that I have those 4 points, remember if it was an ellipse, you just make an elliptical shape out of that, but here we're going to make our box. And then we've got our asymptotes. All right, so for my asymptotes, I would start with your slope. All right, your slope is the change in y over the change in x, so 2 over 1, right? 2 over 1. So my slope is plus or minus 2 over 1, or just 2. And then I know it's got to go through the center point, which was 1, comma 2, so I'm going to use point slope form. So y minus 2 equals plus or minus 2, there's my slope, times the quantity x minus 1. And then to find my 2 equations, I'm going to distribute 2, so I get y minus 2 equals 2x minus 2. So that gives me y equals 2x, right? That looks like that equation. And then the other one would be if I distributed a negative 2, so negative 2x plus 2, and if I add 2, I get negative 2x plus 4, and that's pretty easy to double check that you got that right. All right, so I've got my equations and my asymptotes. I can draw in my actual hyperbola now, because this has to open up and down. So you go from your vertices. I do need to indicate where my foci are. So those should be c units away from your center. So a squared is 4 plus 1, which would give me 5. So c is equal to square root of 5. And then for the purposes of graphing, square root of 5 is about 2.2. So I'm going to go about 2.2 units. There's one focal point. There's another focal point away. All right, and to give an exact location of my foci, it's at 1, comma, we started at 2, and we went up or down root 5. Okay, that's a good exact answer. And then my eccentricity, that's just c over a, so c was root 5, a is 2. Then I think I have everything indicated. Okay. Hopefully graphing, I know it looks like there's a lot of stuff on the picture, but it's not too much different than graphing ellipses. Really, the big difference is the c squared formula and then the fact that you have asymptotes. You have to do something with that. All right, now just like with ellipses, we may need to complete the square in order to get it into the proper format. So this is also very, very similar to completing the square with an ellipse equation. All right, so I'm going to try to group my x's, group my y's. Right, here's my original equation. So I am going to put my x's together, x squared minus 4x, and I'll leave a space here. All right, here I have negative y squared plus 2y. Now, here's a little issue right here. Because I'm subtracting, I'm going to change this to negative y squared minus 2y. And then I'm going to add my space. Right, I'll just copy this down. Because you have to factor out, remember if we ever had a coefficient here, we'd factor it out. So just like anything, I have a coefficient of negative 1, so I'm factoring that out. All right, my 6 can move to the other side. All right, so now you complete the square. So what's half of negative 4 squared? That's 2. 2 squared is 4. So if I add that to the left side, I have to add it to the right side. Half of negative 2 is negative 1. Squared is 1. Now, be careful. I didn't add 1. I actually subtracted 1. So we have to subtract this box here. Now I'm going to factor. So I get x minus 2 squared minus y minus 1 squared equals 10 minus 1, which is 9. All right, so my equation should be equal to 1, so I'm going to divide everything by 9. So this gives me x minus 2 squared. And if you want, you can change that to 3 squared. You don't have to. And 3 squared, and that equals 1. So there is my actual equation. And then we're going to identify all of our information. So you can graph first. You can identify stuff along the way, however you want to. I'm going to say that my center is probably where I want to start. So that's at 2, 1. And I'm going to go 3 in the x direction and in the y direction. Right, if this were an ellipse, it would be a circle because we went the same in each direction. But we need to make our box. And then here's my, this is just at, I don't know if I went down too many, but it should have been down 3. So this is just at -2 there. These are my asymptotes. Okay, my asymptotes go up 3 and over 3, so the slope is equal to 1, and this slope is equal to -1. Now it goes through the point 2, 1. So for my asymptotes, it's y minus 1, and it's plus or minus 1 times the quantity x minus 2. So if I solve for y, I get y minus 1 equals x minus 2, which is x minus 1. That's this one, right? And then I could distribute a -1, so I get -1x plus 2. So that gives me -1x plus 3. And that would be this one. Right? All right, so I've got my asymptotes. Now, which direction is this hyperbola opening? Since the x is the positive fraction, it's going to open in the x direction. So these are my vertices, and my actual hyperbola goes left and right. All right, so where are the vertices located? They are 3 units away, so it was at 2, so it's at 5, 1 and -1, 1. My transverse axis is 6 units. My conjugate axis is also 6 units. All right, and then I need to find my focal points. So my focal points will be based on the equation c squared equals a squared plus b squared, so 9 plus 9. So I have square root of 18, which is 3 root 2. All right, for the purpose of putting it on my graph, the square root of 18 is about 4.2. So I'm going to go, this was 3, so a little bit more than 4. All right, so that's really my focus there. And we should say where our focal points are. So the center was at 2, but then I went in the x direction 3 root 2, either adding or subtracting that, but my y coordinate did not change. So there's my coordinates of my focal points, or my foci. All right, and then, the eccentricity, I forgot about that. So c over a, which is 3, and that reduces to square root of 2. So now I believe that we've found everything we need to. All right, almost done. The last 2 problems are working backwards problems. So we're going to be given some information, and you have to come up with the equation of the hyperbola. So for 27, the only information you're given is that the foci are at 4 and -4, 0, and the vertices are at plus or minus 1, 0. For number 29, you're given the asymptote equations. They are at y equals plus or minus 1/2 x, and the vertices are at plus or minus 2, 0. All right, so just like before, it might be helpful to draw it out. If my focal points are at 4, 0 and -4, 0, my center should be right in the middle of those two. Well, where's my center? At 0, 0. So that's helpful. I know that my equation is going to either be x squared minus y squared or y squared minus x squared. But since my focal points are along the x-axis, right, and even if I label my vertices, they're along the x-axis as well, I know that it has to start with x squared. And it's not going to be x minus anything, like x plus 1 or minus 1, right? It's just going to be regular x squared, and there's going to be regular y squared. And I know it should equal 1. So all I need to do is figure out, well, how much left and right and up and down do I go? Well, my vertices tell me that information. So the box that's something like this, I don't know what my y is exactly, but I do know that in the x direction I go 1 unit in each direction. So that's my a value. All right. I do need to use the focal points. That gives me C, so I'm going to use the Pythagorean theorem equation. All right, so we've got the focal points are 4 units away. The vertices are 1 unit away, and I just need to solve for B. So 16 minus 1 is going to give me 15. So B squared equals 15. So B equals root 15. So here I'm going to put B squared, which is just 15. And then they do want you to write the equation so that it's not equal to 1, but it's like in the form ax squared minus by squared equals c, or ay squared minus bx squared equals c. So basically, get rid of your denominators. All right, so what can I do to get rid of my denominators? If I multiply everything by 15, then I'm going to get 15x squared minus y squared equals 15. And then that's your answer. Typically, we would ask you for just this answer, but if it was a multiple choice, it could ask you for the answer like that. Okay? All right, so try number 29. You could pause the video and then see what my answer is and see if it matches up. That would probably be a good way to see if you know what you're doing. All right, so when you're ready, unpause, and I'll show you what the answer is. All right, so I'm going to start with my vertices, actually. They're at 2, 0, and negative 2, 0. So I know that has to be the endpoints of my transverse axis. So I know that I have to start with an x squared. And since my center has to be halfway in the middle, my center is at the origin. So I'm not going to add or subtract any numbers there. All right, so I know that it's 2 in each direction. So that's going to be 2 squared under my x's. Now my asymptotes, remember this little box thing? My diagonals, if you extend your diagonals, those are your asymptotes. And if the equation of my asymptote is 1/2 x, y equals 1/2 x, or y equals negative 1/2 x, that means that it needs to go up 1 and over 2. So along my conjugate axis, I'm only going up 1 or down 1, so that must be a 1 squared on the bottom. That's it. All right, now they do want you to get rid of your denominators, so if I multiply by 4, that should do it. So that'll give me x squared minus 4y squared equals 4. And I believe that we are all done. So these should be your notes for days 7 and 8, I believe. Yeah. So this is days 7 and 8. All right. If you have any questions, make sure that you ask about them tomorrow in class.